So now we're just going to have a look at an example that uses the second derivative test to determine the nature of the stationary points. So this question starts the same as the previous example. Find the coordinates of the stationary points. So we find dy by dx, the gradient function, we put it equal to 0, and we solve the equation. So if we divide that quadratic through by 6, and then factorise, we get the x coordinates of the stationary points at x equals 2 and x equals minus 1. Then to find the y coordinates, we can sub those x coordinates into the original function, which I've done here. So when x is 2, substitute in 2 and we get y is minus 16. And when x is minus 1, we substitute in that, we get y is 11. So the coordinates of our stationary points are 2, minus 16 and minus 1, 11. So let's just have a look now at using that second derivative to find out if these stationary points are maximum or minimums. So the first thing I'm going to do is work out the second derivative. So there's my gradient function. So if I differentiate that to get the second derivative, that's 12x minus 6. So what I want to do now is find out if that function is positive or negative at x equals 2 and x equals minus 1. So let's start with x equals 2. d2y by dx squared will equal 12 times 2 minus 6, so that gives me 18. So that's greater than 0, 18 is greater than 0, so that tells me that 2 minus 16 is in fact a minimum point, and at x equals minus 1, d2y by dx squared equals 12 times minus 1 minus 6, and that's going to give me minus 12 minus 6, so that's minus 18. So that gives me d2y by dx squared is less than 0, telling me that minus 1, 11 is a maximum point. So we've found the nature of, or we've classified our stationary points, and now all we're going to do is sketch the curve. So let's draw some axes again. If I just have a look at my original function that I'm sketching, all the way back in the question, I can see here that the y-intercept is plus 4, and I can see this time I'm going from a minimum to a maximum on my cubic. Oh no, let's have a look. The minus 1 is the maximum, so it's maximum and minimum again. So I'm going to start with a maximum. I know it's going to go through 4, and then I go down to a minimum. So my maximum point is at minus 1, 11. It goes through a y coordinate of 4, and my minimum point is at 2 minus 16. So there, I've sketched my curve. So to have a practice of that, I'd like you to have a go at these questions from exercise 8F, and then there's just an extension question on the end. If you just pause the video now, because what I'll do is before I stop recording, I will show you the solution to the extension question. So pause the video and have a go at these questions, and then you can just play it again to get the answer to the extension question.